Hello, welcome to the course of UAV. So today we are going to discuss about the drone. In this chapter we will discuss about IoD, that is Internet of Drone, and the type of network. So starting with the very first, that is IoD, Internet of Drone. So the Internet of Drone is an architecture that is designed for UAVs, and it will provide the synchronized access to the controlled airspace. So here the drone will provide the navigation services between the location that are known as nodes, and the architecture will have a different zones, and each zone is supervised by one or multiple zone service provider, that is GSP. So however, here the one difference is that in this architecture that more than one GSPs can participate in managing the same zone. So next is about the ongoing work according to the IoD. So the ongoing work is firstly done by NASA. The NASA UTM, that is Unmanned Aerial System Traffic Management. Here it define a project that organize the conference, and here it will decide to begin the preparation of low altitude traffic management, which will be proposed to the FAA, that is Federal Aviation Administration. And whereas Amazon and Google published the white paper where it is describing or using the search strategies for managing the airspace and coordinating air vehicle through onboard system requirement. So these are the two companies that are doing the ongoing work over the Internet of Drone. Next, we will discuss about the large scale network. So to deploy the IoD, we have to study about the three large scale network. So the architecture of IoD is based upon these three large scale network. First one is Air Traffic Control Network, ATC network. So here the ATC has a strong relevance to IoD for efficient utilization of the airspace and to maintain the collision-free navigation. So it is a service which provides the ground-based air traffic control, and it will direct the aircraft on the ground and through controlled airspace. So its primary aims are preventing collisions, organizing and accelerating the flow of air traffic, and providing information and support for pilot. So it's an integral part of an IoD architecture. Next, here let's discuss about the example of US, that is ATC network of US. So here the FAA, that is the in charge of regulation and air safety. It divides the US airspace into 24 areas that is managed by the 24 ARTCC, and these two ARTCCs have bilateral letter of agreement with each other to communicate. So here each ARTCC divides airspace into 20 or 80 sectors. So here next, each sector is controlled by the one controller, and it explains how aircraft must transition from one ARTCC to another and the bilateral letter of agreement. Whereas flight plans are submitted to entity ATC as CC. So it will have a full record of the flight plans. So here the ATC has a main role to keep prescribed separation between the all aircraft. So this is the example of ATC network of US. So here the ATC has some problem to deploy, like in case of increase in number of drone and limited airspace at a time result in difficult use of centralized entity, that is ATC SCC, for the load prediction and assignment. It means in case if there is an increase in number of drone in the limited aircraft, then it will become difficult for the ATC SCC for the load prediction and the assignment. So whereas the another problem is free flight with IoD is also difficult due to the limited airspace, obstacles such as building, birds, and high level of congestion. Next is the cellular network. So here the cellular network as a network having a cells shape of hexagon, and it has a number of base stations. So here in case of drone, it is less expensive to hold the drone on the ground than to allow it to take off. Similarly, it is also difficult to ground it or hold it due to the lack of resources. So in cellular network, during handover process, BSC doesn't know the next cell to which mobile user will move. But in IoD, the source and destination is known for the drone, and which will allow the more optimized utilization of the network resources. So here the IOD has a design philosophy that is similar of cellular telecommunication network, and here the central entity design like MSC is not good for the IOD because it will not know about the source and the destination of the drone. Next is the next network is internet. So here the layer architecture of internet is useful for IoT, and here the each layer communicate with each other for the completion of task. So first one is routing is performed in internet as well as IoT network, but in IoT will require need a longer computation time. So it will require a longer computation time to allow calculation of more optimal route, and IoT will adapt a routing technique and adjust them accordingly. Next is dropping of packet, which overload the system, only done in internet as the packet is buffered and can be resent, and it is a cheaper mode. Whereas in case of IoT, it is not possible to drop the drone since they are physical object, and the only option is to remove them from the airspace by ordering them inland and providing resources them to execute a landing order, which is expensive task. So these are the three large scale network that we studied to architect the IoT, that is Internet of Drone, to make the IoT architecture. So this is all about drones. Thank you.